Hey everybody, I am sorry that I could not join you this evening, but I found out this morning I have strep, and I figured that none of you would like me to share that with you, and I would also prefer not to share it with you. So, thankfully, Dr. Delgado was kind enough to let me do my presentation remotely. So, I guess rather than standing there, you all can watch what I have to say. Now, since none of you get a redo on your presentation, I'm going to do this all in one take. Hopefully, it goes all right. The title of my proposed study is 404 Class Not Found, a study of access to AP Computer Science. In situating my study, I want to start out with some facts and figures to kind of let you know where I'm coming from. So the first number that I want to give you is 300,000. That is the number of computer science jobs that are expected to be created between now and the year 2020, and there are expected to be far fewer than that computer science degree earners. So there's going to be more computer science jobs available in the next couple of years than there are going to be candidates that are qualified to fill them. The second number I want to give you is 102,280. That is the median income for a software developer who's got a bachelor's of science in computer science. So if I think about jobs where you are putting together a educational requirement to expected salary ratio, computer science seems like a fantastic way to go because it's one of the few jobs where a four-year degree can get you a six-figure salary pretty reliably. Now, here's a couple of graphs that I want to show you. So this first graph is for the American population. That 33% right there, that represents the proportion of the American population that is not white or Asian. So these individuals identify as Black, African American, Hispanic, Latino, etc. The 67% is the proportion of the American population that identifies as white or Asian. And I'm going to talk here in a little bit about why I am lumping white and Asian together, but keep your eye on that graph as I go through the next couple. So the next one, computer science degrees awarded in 2015. 77% of those degrees went to individuals who were white or Asian. For the tech industry at large, 83% of technical jobs are held by individuals who are white or Asian. And when we are looking at a large tech company such as Google, 91% of Google's tech workforce is either white or Asian. Now, I have lumped white and Asian races or ethnicities together for my study because if we look at the demographics of the tech industry, they are overrepresented relative to the proportion of the American public that they occupy. So down the road, when I'm talking about my actual study, I'm putting white and Asian together purposefully because they are overrepresented within the tech industry. Another graph I want to show you that led me to start thinking about the study that I'm doing. Last semester, just out of curiosity, I went on to North Carolina Department of Public Instruction's website and I pulled down their data for the demographics in their school, and then I cross-referenced that against the College Board's listing of which schools do and do not have AP Computer Science courses. The red line that runs across the middle there represents a school population that is 50% white and Asian and then 50% other. If you look above that line, the green spots are schools that have AP Computer Science. So I found it interesting in looking at this graph that most of the AP Computer Science programs in Wake County high schools are in schools where the proportion of the student body that is white or Asian is greater than 50%. And then once you drop below that 50% mark into student bodies that are predominantly African American and Latinx, there are only two AP Computer Science programs, and one of them is a Tech Magnet program. So this is a graph that got me curious in thinking about this idea of access to AP Computer Science courses. So why am I interested in this beyond the things that I have just shown you? I've done a lot of work, not a lot of work, I've been very curious about why there is so much underrepresentation of minority groups in the tech industry. And in doing a literature review, a couple of the reasons that stuck out most frequently were lower technology availability in the home. So minority homes are less likely to have broadband internet, less likely to have a home computer or a laptop. Oddly, though, more likely to have a smartphone. But one of the hypothesized reasons that there is not as much interest into going into the tech industry is lower, um, I guess, lower exposure to technology at home. Also, a lack of role models in the industry. So, as I've just pointed out through the graphs a little bit earlier, the tech industry is not one where minority teenagers are likely to see people who look like them. And then reduced access to adequately trained teachers and opportunities to learn. So, Margolis, very famous book, 2008, and then again in 2010, titled Stuck in the Shallow End, wrote at length about how minority populations have much less access to high quality tech education in their schools, where in a predominantly white or more affluent school, you may see computer science courses, you may see courses on graphic design or computer aided drafting. In schools that are lower income and tend to have more minority students, the computer offerings are more like learning to use the Microsoft Office suite. So the quality of the tech education that these two populations receive seems to have quite a bit of disparity in it. One of the solutions that has been proposed while he was in office, President Obama put forth the Computer Science for All initiative, which was in recognition of the fact that to be successful in the future and to access some of those 300,000 computer science jobs, students will need to have opportunities to access a quality computer science education. And through access to those courses, students have the ability to counter any misconceptions they have about what it means to be a computer scientist or to work in the tech industry. Encountering these courses can enhance their interest in working in the field, and it can build their self-efficacy. And as numerous authors have shown, science self-efficacy is a good indicator of students continuing on into a career. So these initiatives were put forward in an effort to bring some diversity to the tech industry. And my interest in doing this work is to understand if there currently are disparities in access to specifically AP computer science classes, and I'll talk about that in just one second. So the three AP computer science courses, there's AP Computer Science A, AP Computer Science AB, and then AP Principles of Computer Science. The aim of all three of those, particularly AP Computer Science Principles, was to broaden participation in the field of computer science. But they can only broaden the participation if students have the opportunity to take those courses. There are no existing studies that I could find investigating access to AP computer science courses, and this is something that really piqued my interest. Is I went out to look for any similar studies. I went to look for any work that had been done to understand who does and does not have the opportunity to take a class in AP Computer Science. And the only thing I ran across was a single white paper out of a research institute in California that looked at access in California's high schools to AP Computer Science courses. But beyond that, it seems that no work has been done in this area, or if it has been, it has not been published in a notable enough journal that it showed up in any search results. The theoretical framework that I'm using for this is the equity, equality, goal-oriented model from Espinoza. Through this model, Espinoza tries to do a number of things. He tries to define the terms equity and equality within the context of education. And he defines those terms, equity and equality, in terms of access to courses, access to resources, access to teachers, access to outcomes, meaning like a quality education overall, and future career prospects. In this model, Espinoza lays out multiple facets of the educational process, and goes through for each of those facets and talks about what equity looks like and what equality looks like. And he talks about what each of those looks like at a different level. So what does it look like at the level of a student? What does it look like at the level of a group? And what does it look like at the level of a system? For this study in particular, I focus on his definition of equality for all, which he defines as to guarantee all people equal access to quality education. So he calls that the access part of the educational process, the same level of educational attainment, that is the survival, so basically staying in the educational process, and the same achievement on tests, that is educational outcomes, and the same occupational status and incomes. So in thinking through this idea of who has the ability to access AP computer science courses, I look to Spinoza's definition of equality for all. The overarching research question that guides my work is, what is the relationship between the demographics of a North Carolina high school and the availability of AP computer science courses? And there are two sub-questions. The first one is, what is the nature of the relationship between a public high school in North Carolina's racial ethnic composition and the school's provision of AP computer science classes? Second one is, what is the nature of the relationship between the percentage of a public high school in North Carolina students that are eligible to receive free and reduced price meals and the school's provision of AP computer science classes? And I approach this proposal with two hypotheses. The first one is that the likelihood of a school offering an AP computer science class will be directly proportional to the percentage of the student body that identify as either white or Asian, a trend I saw in that graph that I showed you a little while ago. And the second hypothesis is that the likelihood of a school offering an AP computer science class will be inversely proportional to the percentage of the school's student body that is eligible to receive free or reduced price meals. As far as the study design goes, it is a research question-driven secondary analysis of existing data. I'll talk about my data sources in a minute, but the data I would like to draw from and analyze is already out there. So it is a secondary analysis of data that's already out there. In their article, Cheng and Phillips talk about two different approaches to analyzing existing data. There is the data-driven approach and the research question-driven approach. In the data-driven approach, the researcher has the data in hand and looks through that data to figure out what sorts of questions it can answer. In the research question approach, the researcher has a question and then goes out and finds data appropriate to address that question. I am taking the research question-driven approach. My data sources, there are three of them. The first being the AP Course Ledger. So if you Google AP Course Ledger, a site from the College Board will come up where you can type in any school and it will tell you what AP courses that school has offered every year for the last 10 or 15 years. So I could type in, I don't know, Green Hope High School out of Wake County, and it would tell me whether or not they have an AP computer science course. The second one is the North Carolina Department of Public Instruction's Pupils and Membership by Race and Sex School Year 2016-17 report. That report provides me with the racial and ethnic composition of the schools that I will be looking at. And then free and reduced meals application data provides me with the information on how many students are eligible for free and reduced price meals. I am using that as a proxy for the socioeconomic status of the school. There's an article by Nicholson, 2014, I think, that talks about how free and reduced price meals stand in as a decent proxy for the socioeconomic status of a school. Regarding my actual method, the N is 727 public high schools in North Carolina. There are 1,000 plus, but several, I guess 300 or so, are private. So I'm focusing on just the public high schools because they're the ones that have data publicly available. With regard to variables, there are 4 of them that I am considering in doing this analysis. My outcome variable is whether or not a school offers a course. So it is a categorical variable. Yes, they have it. No, they don't. That'll be coded as a 1 for yes or a 0 for no. The first predictor variable or independent variable is the combined percentage of white and Asian students. That will be treated as a continuous variable, as a percentage. The second predictor variable will be the percentage of the student body that is eligible for free and reduced price meals, also a continuous variable. And then a potentially confounding variable is the size of the student population. And as I've thought through doing this work and doing this analysis, I've realized that a school offering an AP computer science course may be heavily dependent on the actual financial resources that school has. And in North Carolina, our schools are funded per pupil. So if you have more pupils in a school, then you inherently have more resources. So I recognize that that could be a potentially confounding variable for this study. Regarding analysis, I have gone around, I have looked, I've only taken one thus far, so this has been kind of a tough nut to crack. Gone back and forth with Dr. Delgado, and after going back and forth with him, my analysis is probably different than this right here. Was thinking about doing 2 rounds of analysis, both of them logistic regression. The first logistic regression being the presence of an AP computer science course, the demographics of the student body, and then the population or the number of students at the school. The second analysis being the presence of a course, free and reduced meals, population, and then the size of the student body. The reason that I had split that into 2 different analyses is that the demographics of the school are likely to be highly correlated with the percentage of the population that is eligible to receive free and reduced price meals. So when you're doing logistic regression, you have to separate variables that are potentially collinear. So I split that into 2 analyses. Now, after emailing back and forth with Dr. Delgado a little bit, it seems like hierarchical linear equation, linear modeling, HLM, hierarchical linear modeling might be a better approach, but I need to go do some more reading before I decide whether or not that is the case. So that is my proposed study. Those are my references. Thank you for humoring me and watching this video, and I will be joining you all in class. I think I'm probably on Skype right now, so if anybody has any questions or feedback, I'd be happy to hear it. Thank you. Bye.